Okay, let's do question 7, 8, and 9. So question 7, 7.1. If f of x is equal to 4 over x, determine f prime of x from first principles. Remember, first principles is the one on your formula sheet, or this one, basically, using that formula. With that formula, remember, I'll use the second solution. But then first, you have to find x plus h, that is, you find this one, then you plug it in there. I'm going to use this one, I'll use the second solution. But then starting it, you start it like that, then you plug in there. When you plug it in, you're going to have this. So your f of x plus h is there, f of x is there. Now you just need to know how to deal with fractions. So to deal with fraction, this x times this 4 gives you the 4x. This x plus h times 4 gives you minus 4 times x plus h. Then at the bottom, this x multiplied this x plus h. There you have it, all over the h. Then you simplify. You multiply the 4 inside. You're going to have 4x minus 4x minus 4h. Then the minus 4x cancels out. So this takes each other out. Now another thing that happened here was when they were simplifying, they had 4x minus 4x minus 4h all over x of x plus h. Now they divided, let's put it here, divided by h. Now we change the division to multiplication. When you do that, the following happens. You just duplicate it. When you do that, this happens. So if you change it to multiplication, you're just going to have the following. So it's going to be times 1 all over h. Again, this cancels that basically. So you're going to have minus 4h all over. Now, in this case, they multiply the h. So they said, okay, this h multiplies the x. So it's going to be xh of x plus h. After that, they cancels this h and this h. Then you're left with this part. After that, you put the 0. That means this is the same thing as minus 4 over x plus 0. Then from there, x plus 0 is still x times x is x squared. That's how they ended up with the solution. That's 7.1. Please also check the ticks where they're putting the ticks. Make sure you have those steps there as well when you simplify. 7.2.1, find the derivative. Here you can just do it quick. You know how to do it quick. So in this case, 7.2.1, the easiest because there's nothing you have to do, you just drop. So in this one, there's 2, you're going to multiply it with the 5, you're going to get the 10, minus 1, you're going to get 1 there. Then here you have 1 times 5 is 5, minus 1, 0, then it goes away. This doesn't have an x, that's 0. Get your easy 2 marks. Next one. This one is also easy. The problem is just this. You just have to change it. So x squared. Then you put it as 1 over 3. And then remember the cube root means 1 over 3. Then 2 times 1 over 3 is the same thing as 2 over 3. That's how they ended up there. Then you can drop when they remove this after dropping. So this multiplied with 1, it's going to be 2 over 3. Minus 1, it's minus 1 over 3. Here you have a 1. 1 times negative half, it's negative half. Minus 1, 0. X was 0, it's 1. So it goes away. 7.3. 7.3 says, show using relevant calculations why it is not possible for a tangent drawn to the graph of P. So they give you the equation of P to have a negative gradient. Remember, for any curve, the gradient is defined by the first derivative. So if you find the first derivative, you have an expression that will give you the gradient. There it is. Now, if you want to find the gradient at a point, you just find that point, that x, you put it there, and then you get the gradient. Now, in this case, when you're going to put that any x, so if you look at this one, the 3x squared, on the x, if you put any number, the answer will be positive. So you can't make this negative. That is, if you choose x being negative 100, the answer still will be positive because of the squared. So that's basically what they're explaining here. So 3x squared is always going to be positive. Or you can just say x squared will always be positive. Therefore, the whole thing will always be positive. You can use that language that I'm using now. You can say 3x squared is always positive. Therefore, 3x squared plus 2 will always be positive. Meaning, remember, this is the gradient, meaning the gradient will always be positive. Then you answer it. Instead of using the language, if you're uncomfortable with it, you can just write it like this after finding the first derivative. Question 8. Question 8 is the cubic function question, okay? So it says the graph of y equal to ax squared plus bx below represents the derivative of f. Oh, so f, again, f as a cubic, they just drew its derivative. So it is given that this is important, so I'll just put them here for this case. So this is the inverse. So saying on the inverse, if you put x equals to 1, if you put x equals to 1, your y should be 0. So if x is 1, y is 0, x is 1, I believe it's going to be here. I can change that, but let's put it there now. That means here it's 1. If x is 3, y is 0, that means this one is 3. Because here y is 0. Here it says if x is 0, y is 6. So here x is 0, y is 6. That means here it's 6. Now before you go far, you just have to remember as well that the intercepts are basically the turning points of our cubic function. And also, look at this one. This one is a smiley. That means this a is positive. If this a is positive and this is the first derivative, that means the original also. That means that that means this a was also positive. Why is that important? Because now it means the cubic, you know what's going on with the cubic. The cubic, if it's positive, that means starts by going up. Go back to the side. If a is positive on your cubic, that means your cubic starts by going up and goes down, goes up again. Now, based on what you just did, that means here the x will be 1, and then here the x will be 3. So the x-intercepts are the turning points for the cubic. Now let's answer the questions. 8.9, write down the coordinates of the stationary points of f. Again, the turning points. They just want the x. So it's x and 1, x and 3, what I just said basically. 8.2, for each values of x is f strictly decreasing. F, not the inverse. Remember, the drawing sketch is the inverse. Not the inverse, the first derivative. So now the sketch I drew here will help because you just find where it's decreasing. It's decreasing between 1 and 3. So there, as you can see, the answer between 1 and 3, between this 1 and this 3, that's where it's decreasing. So having this sketch helps a lot. 8.3, explain which values of x, the stationary point of f, will be a local minimum. Again, now the sketch, you know, here it's going to be local max, here it's going to be local min. So at x equals to 3. Otherwise, you can use second derivative at that point and then put the value and then you'll know. But in this case, you don't even have the formula, but then you can tell that from the sketch that I just drew now. You can tell that at 3, it's 0, therefore it's a turning point. And then second derivative will be positive. So you can use your sketch and just say there will be local minimum. That means the second derivative will be positive. You can just use this one. But then the sketch helps. You can get the answers quickly with the sketch. 8.4, determine the x-coordinate of the point of reflection. Again, back to the sketch. So point of reflection, you know, it's in the middle there. Is it different color? It's in the middle there. So if it's in the middle, you can find it using these 2 points. You know, this is 1 and 3. So the middle of 1 and 3 you can find by just saying this plus this divided by 2. Exactly what happened. To find that x, you just say the turning points. At the 10 points divided by 2, you get that x equal to 2. That means here it's a 2. That's the point of reflection. For 8.5, for which values of x is f concave up? Again, our sketch helps. So it's concave up here. That is from 2 and greater, or after 2 basically. So that is x is greater than 2. As you can see, bigger than 2. Question 9, the last question. It says the mass of a baby at the first 30 days of a life is given by this formula, where t is from 0 till 30. T is the time in days, so t is days. And m is the mass of the baby in grams. 9.1. Write down the mass of the baby at birth. At birth, the time is 0. Day 1 is 0. Yes, it's day 1, but then the first moment, its time is 0. That's why you put 0 there, you get 300. That means at birth, the baby weighs 3 kg or 300 grams. Here they didn't ask about the unit. They said the baby is in grams, so that means the equation will give you this one. This one, if you know, they didn't ask for it. So the second one, 9.2, a baby's mass usually decreases in the first few days after birth. On which day will the baby's mass return to its birth mass? So birth mass is 3,000 grams. So when will it get there? Just use the formula, substitute the mass. The mass is 3,000. You want to know what will be the days. From there, move the 3,000 that side. You're going to subtract. You're left with this common factor t squared. Then t squared equal to 0, or t minus 9 equal to 0. So there's 0 this side. This is 0, this is 0. Then you solve t0 and t9. That means after day 9, at birth, t0 means at birth, and t equals 9 means after 9 days. That's what they want. 9.3. On which day will this baby have a minimum? Minimum, like if you've done it, you just find first derivative, equate it to 0, solve for t. So it will give you the day. So that's the first derivative, equate it to 0, solve for t. That means on day 0 and day 6. And then on which day will the baby's mass decrease the fastest? In the context of, look at the equation. The equation is a cubic. With a cubic, here in the middle here, the gradient, it's where it's decreasing the fastest, increasing or decreasing the fastest, the point of inflection. So the point of inflection, it's where it's increasing the fastest or decreasing the fastest. That's the point of inflection. Always, just know that. So that means we just need to find the point of inflection in this case. How do we find point of inflection? We just find the second derivative there. Equate it to 0, solve for t. Or using symmetry, that is, you know, if you understand what you did before. Because on 9.3, you just found the turning points basically. So you found that it's going to turn here at 0, going to turn here at 6. So to find this, you just say 0 plus 6 divided by 2, you're going to get 3. That's the same point of inflection. Otherwise, just do how they did it on 9.4. I'll stop there.